This is KK Mathematics, the solution to your mathematics. Today we'll be doing the domain of a function. How to find the domain of a function. So, one of the key things we need to know here is, first of all, what domain of a function is. Now, the domain of a function is actually a set of possible objects, okay, that have images, or we can say that the largest domain of a function is a set of possible values of x, which makes the function exist or define. And one important thing you need to know here is that the domain excludes the values of x, which makes the function undefined if such values exist. Undefined means the function does not exist. So if we consider what a set of real numbers, though these are a set of real numbers. So if you don't know what a set of real numbers are, these are a set of real numbers, and what we are actually saying is that for any function that exists everywhere, then we write it as such. That is a set where x is the element of a real number. So what that means is that everywhere within a set of real numbers, it means that the function exists everywhere in a set of real numbers. So that being said, there are two things that makes a function not to exist. The first one is if the denominator is 0. You can try punching this on your calculator. If you have a calculator with you, if you punch an integer or a real number and divide it by 0, your response or answer the calculator will give you will be marked error. That's because it doesn't exist. There is nothing as such. So the second point or second thing that makes a function not to exist is when you have the square root of a negative number. The square root of a negative number makes the function not to exist. You can try that by punching it on your calculator, and you end up with a result marked error. So it's very important for you to consider these two important criteria that helps you to know whether a function does not exist in a certain areas. With that, let's consider how to find the largest domain of a rational function. The first thing to do is to equate the denominator to 0. The second thing is to find the values of x. The third thing is the value. After finding the values of x, then we need to know that those things, the values that we found, is what makes the function not to exist. That means that if we substitute or replace our x value with the value that we have, it makes our denominator 0. And that means that the function does not exist or is undefined. And fourth important thing to do here is finally, you conclude and state the boundary where the function exists and where it does not exist. So we're going to try an example here, okay? And this example that we're going to try here, we are actually going to follow every single statement here, single points that we made here. So let's consider this example here. So we have k of the function of x equal x plus 5 all divided by x minus 3. So the first thing we do, as we said earlier on, is to equate the denominator to 0. And so that's what we're going to do. Here, our denominator is x minus 3, so we equate it to 0. Yes. And then we find the value of x. So we find the value of x, and obviously that's x equals 3. Then the next thing we do is what? So we know that if we are to replace this value here, 3, into the denominator or into the x, wherever x is, notice that our answer here will be what? 8 divided by 0. And we know that if the denominator is 0, then it means that the function does not exist. So with that being said, we then can conclude and say that the function can exist everywhere in real numbers or in a set of real numbers, except when x equals 3. So if you consider a Cartesian plane, for instance, that means that in all the numbers of the Cartesian plane, the function will exist, but except where x equals 3, because at x equals 3, the function ceases to exist. So that we conclude by saying, therefore, we conclude that x is such that x is what? Is an element of R, or can be found or the values of x is what? They are the element of a set of real numbers, except when x equals 3. So this becomes our domain of this function there. And this brings us to the end of today's lesson. I hope you've enjoyed this lesson, and this is the part 1 of the lesson. Be expecting part 2 the next video. Wish you all the best. God bless you. Please subscribe, like, and share. This is KK Matics, the solution to your mathematics. Bye for now.